Hi guys, and welcome to Little Rescuer's Heart Dissection. So today we are going to have a look at and dissect a heart. So it's not a human heart, but it's a heart of a sheep. So in a little bit we will have a look at that and we'll cut it open and we'll see what it looks like inside, because a sheep's heart is really similar to our heart. But first I just wanted to show you guys what our heart looks like on the outside, but also on the inside. Okay, so our heart is about the size of our fist. So put your own fist out, have a look at your own fist, and that is how big your heart is. Okay, and your heart is a muscle. Okay, so it's a super important, the most important muscle in your body, because it never stops working, it never stops beating, okay? So it's really important that we keep our hearts strong and we keep our hearts healthy, all right? Now, sometimes people think that our hearts are this shape, a bit like a love heart that you might draw or you might see on a card, but our hearts are not that shape, okay? This is the shape of our heart. So at the top, it's quite flat with some tubes coming out of it, and then at the bottom it's a little bit more rounded, okay? And our heart is completely split down the middle. So there is a right side and there is a left side, and the blood that goes into the right side of the heart never crosses over into the left side of the heart, and vice versa. The blood on the left side of the heart never crosses over to the right side of the heart. So it comes in the right side, goes back out again, it comes in the left side, and it goes back out again, okay? And inside of our heart, we have got 4 rooms, or 4 chambers, like the chambers in a castle, okay? We've got 2 smaller chambers at the top, and they are called the atria, okay? So we've got the right atria on the right side, and the left atria on the left side. And then the bigger rooms, or the bigger chambers, are called the ventricles. So we've got the right ventricle at the bottom and the left ventricle at the bottom, okay? And one side is much thicker and much stronger than the other. Which one do you think it is? Do you think the right side's stronger, or do you think the left side's stronger? So the left side is stronger. That is because the left side of our heart pumps the blood to every single part of our body. So it goes right up to our head, right down to our feet, and everywhere in between. So the left side has to be strong because it has to pump the blood all the way around our body. The right side of the heart is still super important, but it isn't quite as strong, because the right side of our heart pumps blood up to our lungs. And do you know what we get from our lungs? So when we breathe in and all of that air goes into our lungs, there's something super important that our body needs from that air. Do you know what it is? Yeah, it's oxygen. So when we breathe in the oxygen in our lungs moves across into our blood, and then the blood takes the oxygen back to our heart and then pumps it all the way around our body, okay? So let me ask you this question. Why do you think some of these tubes are red and some of these tubes are blue? So the reason is the red tubes carry blood full of oxygen, okay? And the blue tubes carry blood with no oxygen in, okay? So the blue tubes are veins, okay? And the red tubes are arteries. So you guys may have heard of those before, okay? And normally arteries, so it begins with an A, carry blood away from the heart. And veins, so veins is spelled V-E-I-N. And the last 2 letters of vein, I-N, spells in. So veins carry blood into the heart, okay? So Veins and arteries are super important, and then there's also really, really small, tiny little blood vessels, which you can't see on our heart, but they're all throughout our body, and they're called capillaries. And a capillary often joins an artery and a vein together, and those little tubes are the ones that you cut if you fall and graze your knee, or you graze your elbow, or you cut yourself and you need a plaster. It's normally the capillaries that we cut, because only a little bit of blood comes out of those, and they heal really quickly, okay? So let me ask you one more question. If you took all of the arteries and all of the veins and all of the capillaries out of your body and you stretched them, how far do you think that they would stretch? Have a little think. How far do you think? All of the tubes, you took them out of your body, all of your veins, all of your arteries, all of your capillaries, how far would they stretch? So the answer is 60,000 miles. That is to Australia 6 times. So we've got a lot of tubes in our body that can carry the blood around. Now I need you guys to use your imaginations, okay? So I want you to imagine that this blue van is blood with no oxygen in it, okay? That's called deoxygenated, all right? So it's got no oxygen in it, it's deoxygenated, all right? And then this red car is blood that is full of oxygen. It's bright red, it's oxygenated blood, all right? So we're going to start with the blue truck. So the blood is coming back to the heart, and it comes into the right side of the heart. So it's been around the body, it's giving all the body everything that it needs, all of the oxygen, and now it's coming back, okay? So it's back to the heart, and it comes in a big vein called the vena cava, okay? It's a really big, big vein in the body. And then it comes down that vein into the first little chamber, the right atria, okay? And then it gets to 2 little doors, and this is called a valve, okay? And what this does is it stops the blood going backwards, okay? So the blood now has to really push and really force its way through this valve to get into the big room or the big chamber at the bottom, which is the ventricle, okay? Once the blood gets through that valve closes up again, so the blood can't flow backwards. So the blood only flows one way. And now that the blood's in the bottom, in the right ventricle, it's going to turn around and it's going to push up through another door, okay, or another valve, into the pulmonary artery, and it's going to go away, artery away from the heart. So when it leaves the heart, when it leaves the right side of the heart, it goes to the lungs, okay? Remember, the right side is a little bit smaller because it only needs to push the blood up to the lungs. Once the blood gets to the lungs, it gets full of oxygen, okay? So it stops being blue, now it's bright red, okay? So now the blood comes back from the lungs and it comes into the pulmonary veins. So it goes into, okay, into the heart. So it goes into the left atria, okay, the small room at the top. It pushes through that little door, okay, so it pushes through that valve, and then it's into the big room at the bottom, the left ventricle, and then all that nice oxygenated blood is pushed through another door, and it moves out of this really big artery called the aorta. So that's the biggest artery in the body, and it sends blood to every single part of the body, goes out of the aorta, and it goes all around the body to feed it with oxygen and glucose, okay? Now, the heart is the only place in the body where there is deoxygenated blood in an artery because it's leaving to go to the lungs, and then when it comes back and it's full of oxygen, that oxygenated blood comes back through a vein, okay? And that's the only time it ever happens in the body, all right? That we've got deoxygenated blood in an artery and oxygenated blood in a vein. Everywhere else in the body, arteries carry nice oxygenated blood, and veins carry deoxygenated blood. Inside of our heart, we've got electricity or electrical activity, okay? And that really helps our heart to beat, okay? So, the electrical activity in our heart is in a circuit, okay? So we're born with it, and it continues around our heart for our whole lives, all right? Now, it starts in the small room at the right atria. That's where our first little bit of electrical activity starts. It's called a node, an electrical node, okay? And then it moves a little bit further down the right atria. It moves across to the left, and then it moves down this bit of the heart, which is called the septum, which is a bit like the septum of your nose. It splits your nose between your left and right nostril, and it splits your heart between the left and right side of your heart. So then the electrical activity moves down there, and then it shoots up the bottom of the heart. So that really, really helps your heart to beat, or what is called contract, to move the blood through the heart and then through the body. This is the heart that we are going to dissect and have a look at, okay? So this is the sheep's heart. Remember I said it's about the size of your fist? This one's quite a big heart. And remember that I said it was a muscle, and it lies in the middle of our chest, but ever so slightly it's tipped to the left. See how our heart on here is slightly tipped to the left? That's what this one does. Tips ever so slightly to the left, okay? So your heart's beat anywhere between 70 and 110 times a minute, okay? When you're grown up, then your heart beats on average around about 80 times a minute. So if you lived until you were 80 years old and your heart beat 80 times a minute, how many times in your whole life do you think your heart would beat? Have a think about it and I'll tell you at the end, okay? So, here is the heart, and we are going to decide which side is the left side of the heart and which side is the right, okay? I'm going to lay it on here. And can you remember which side is the thickest and the strongest? Yeah, it's the left, isn't it? So I'm going to have a feel of this side, feel of this side. And this side, which is my left, as you guys are looking at it, it'll be your right. But this is the left side of the heart, okay? And this left side of the heart is definitely the strongest, okay? This side's pretty strong too, but the right side isn't as strong, because remember, the right side only sends the blood up to the lungs. Let's look at the tubes at the top of the heart. Now, the tubes here, the two tubes here, are quite light. The walls are quite thick, and these are the arteries, okay? So these are the arteries that carry that nice, fresh, oxygenated blood. These ones, 1, 2, these are a little bit darker, a little bit thinner, and they carry the deoxygenated blood. So these tubes are the veins, okay? And then these little bits here, so this little bit on the left side, and this little bit on the right side, this is the atria, okay? So the first little room, or the first little chamber that the blood comes into, all right? Now, if we think of the way that blood flows through the heart, remember it first comes into the right side of the heart, into that big vein, the vena cava. It goes into the atria, and then it goes through the doors, doesn't it? Into the big ventricle at the bottom, then it comes out again through the pulmonary artery, okay? And can you remember that that side of the heart goes to the lungs, okay? And then it goes up to the lungs, it gets lots of oxygen, and it comes back. And when it comes back, it comes into this vein, the pulmonary vein, goes into the atria, and then it goes down into the left ventricle at the bottom, and then up and out of that big, thick aorta, and it goes all the way around the body. Okay, so I'm going to show you guys with some straws, and we'll see if we've got them in the right place, okay? So we know that the blood in the right side of the heart here has got no oxygen in it, because it's already been around the body and it's come back to get sent up to the lungs to get fresh oxygen. So I'm going to use the blue straws for deoxygenated blood, and we'll see if we're in the right place. So, comes in here, and it goes into the vena cava, into the right atria of the heart, and then down into the right ventricle, okay? And then it comes out of the pulmonary artery to go up to the lungs, okay? So we know that that blood should be deoxygenated, so it's blue. And then when it comes back from the lungs, it's fresh red blood, full of oxygen, it's oxygenated blood, and it goes into the pulmonary vein, into the atria and down into the ventricles. And then it comes out of the aorta. Okay. This line down here, this line here, is the coronary artery. So because the heart's a muscle, it needs its own blood supply. So blood has to go through the muscle of the heart to make sure that the heart works properly, okay? So that's the coronary artery, which travels down the heart and around it, okay? So we're going to cut the heart open now, and we're going to have a little look inside. So first, let's go down the right side of the heart, okay? So I'll start up here. I'm going to cut into the muscle, and we'll see if we've got our straws in the right place for that deoxygenated blood. So as you can see, it's quite thick. Oh, look at that. And inside of here, we have got some blood clots, okay? Take those out. And this is often what happens after the sheep has died, okay? Often the blood, because it isn't getting oxygen anymore, will just clot, okay? So sometimes there will be blood clots in the heart. So let's see. I think we've got that right, haven't we? Got a blue straw in there and a blue straw in there. Brilliant. So let me cut that a little bit more. Open it right up through that muscle. Okay. So you can see, take those straws out, into the inside of the heart. This is the right ventricle of the heart, so the big room in the heart. And this, it's called a band. This band here is called a moderator band, and it's in the right side of the heart, in the right ventricle, and it stops the blood coming through too forcefully. So it doesn't let the ventricle really expand and get too big. Okay, so that's called the moderator band. And then underneath the moderator band, underneath here, oh, pull that out of the way. This is one of the valves, okay? So this is one of the valves that lets the blood move through the right side of the heart. And down here, at the bottom, these are heartstrings, okay? So this helps with the heart when it beats, okay? When it contracts and the blood moves through. And they're called chordae tendineae, okay? And we call them heartstrings, and sometimes people say, ooh, they're pulling on my heartstrings, okay? You might have heard people saying that, but they are very important to our heart beating. Now let's have a look at the left side, the thick left side that takes blood all around the body, and see if we've got our two red oxygenate straws in the right place, okay? So let's cut down here into the muscle. Now that is much thicker, much harder to cut into. Let's have a little look. Open that out to cut a little bit more. Okay, now we are in the right place, definitely in the left side of the heart. So that's the two red straws and the oxygenated blood. So let me take those out. Okay, so you can see how massively thick the walls of the left side of the heart are compared to the right side, okay? They're really thick, and we know that's because the left side of the heart has to send the blood everywhere in the body, okay? I'm just going to completely cut this open. Okay. So have a look in there. Now, you can see the heartstrings in here really, really clearly. And they are really tough. So even though I'm pushing, I'm pulling up there with my scalpel, they are not cutting at all, okay? And then we've got some really big papillary muscles here. The muscles that are mega important for the heart to beat, okay? We've got another valve again up here. And the heartstrings, or the coordinate tendon, are really, really helping with that, okay? So let me see if I can break some of the heartstrings. They're mega tough. They're hard to break, okay? Well, they are really hard to break. Super, super tough. In fact, I can't even do it. But it's important that they're tough because they help our heart beat. And remember that this is the most important muscle in our body because it keeps us alive. And if our heart beats, it can push blood 10 meters. So it's really, really strong and really, really forceful. Okay, so one last time, let's see how blood travels around our body, okay? So it first goes into the vena cava and into the atria. Then it travels down into the ventricles, so that big room at the bottom, and then it moves out of the pulmonary artery and it goes up to the lungs. And then it comes back from the lungs with fresh oxygenated blood and it goes into the pulmonary vein, into the atria on the left side, down at the really big, strong left ventricle and out of the strong aorta, so the strongest artery in the body. So that's the way that it flows on the left side. This is what your heart looks like on the inside and on the outside. Thank you so much for joining us today. I hope you enjoyed it. And the answer to the question I asked you, if your heart beats 80 times a minute and you live till you're 80 years old, how many times will it beat in your life, is coming up now.